Hello friends, in today's experiment we'll be dealing with electrostatics. There are so many materials here with me for paper. Proof plane. We have the Franklin's bell there. We have electroscope here. So quite a lot of experiments to do today. So in this particular experiment, I have some aluminum balls folded here. We have so many of the aluminum balls folded here. I'm going to take some of them. So what I'll do is, first of all, I'm going to charge this surface with paper. Charge the surface with paper. And I'm going to drop some balls there. I have some balls here. Let me drop this one so too. You can see that, look at the way they are behaving. Okay. They are running away. It's the force of repulsion. Okay, so let me bring these ones in. Bring these ones in. Alright. They are even running away from me. Okay. So I can actually charge this ball with my hand. Okay. Okay. So this plastic material has been charged. Let's see. Running away. Alright, so that's the end of that particular experiment. The next one is to recharge this plastic material again. Okay. I have aluminum foil folded into a ball attached to a thread. So there is a force of repulsion, there is a field here, and I'm trying to touch the ball. Okay, you can see what's happening. My finger is not stationary, but see, there's a repulsive force. Look at it. Alright, so that is that particular experiment. Okay, I can also charge it in my hand and try it again. Still getting the same results. Alright, so that's the end of that particular experiment. So then we move on to electroscope, but this material is a proof plane, and it has a circular disc and attached to a PVC pipe. The setup is just like this. So I'm going to use it. I'm going to make an electeophorus. Basically, a proof plane is a device for transferring of charges. So first of all, I'm going to charge this with wool. I'll charge it with wool. I'm charging it with wool. So charging it with wool or charging with paper, this board becomes negatively charged while the wool becomes positively charged. Alright, that's in the triboelectric series. Okay, you can also Google that out, the triboelectric series. Alright, so I have charged it. I have a circular disc and it's attached to it. It could be a four-corner disc so that it prevents coronal discharge. Alright, so watch this. Okay, the leaf diverges. See? Alright, so it's actually affecting it. Okay. Alright, so, okay. So, for now, what I'm going to do is to attach a wire. I'm going to attach a wire to this scan. So what I'm going to do is a Franklin's bell, and I've attached the wire already here. I have to strip it first to make contact. Attach the wire there, well sellotape. Then I have to attach this wire to this plate, and seal the exposed part so that there won't be any coronal discharge. So let's see what happens. First of all, let me charge this board. Very well. For better results, it has to be on top of a plastic material, or you may not get the result actually looking for. So this is to say that electricity moves from a higher potential to a lower potential. Alright. So in that way, we can get a flow. Let's see what happens there. You can see the movement there. So the Franklin's bell. I touch it, the motion ceases. Okay. So I can actually charge with my hand. Let's see. You can see it's moving. What is actually happening is that the charge is being transferred to this particular can, and when the ball you touch this ball, when this ball touches this can, it has the same charge. As a result, there is a repulsion. This one takes that charge away and it comes back to its original position. Okay. Alright. Let me charge it. Let me wait for a while. Let me touch. Okay, so see. Alright, so I'm going to do it without this Franklin's bell. And all I do is okay. So in short, what I did is almost like this. We'll be attaching this to it. Alright, so I'm going to charge it with a wool. Okay, so the wool becomes positively charged and the plastic material becomes negatively charged. Negative in the sense that it has more electrons. Okay, there are more electrons. For the wool, it has there is depletion of electrons, making it positively charged. Alright, so let me drop it. I'm going to make a touch. Okay, let's watch what happens. Okay, you can see. Let's transfer electrons to my hand. I have to touch so that I ground it. You don't have to touch it to ground it. If you leave it for a very long time, it grounds itself. If you leave it for a long time, the electron flow to ground, and if you raise it up, it will still work. Okay, so let's try it. Okay. So let me ground it. Okay, I've grounded it. Okay. So what happens is that this board is negatively charged, while this plate, let's say the bottom there will be positively charged, while at the top it will be negatively charged. There will be repulsion. So once I touch this, the negative charge on this disc goes to ground through my body, okay, leaving this positively charged. Alright, so that is how it works. But if I don't ground it, if I have to leave it for some time, it will ground itself. Okay, I want you to do this experiment. Just leave the disc for some time. You find that without even earthing it, it has a way of earthing itself naturally. Okay, at first there is a repulsion. Let me touch it again. See, at first there is a repulsion. It's attracted to my hand. Okay, let's transfer electrons to my hand. Alright, we will have use it to flash a light bulb or even a neon lamp from the tester, but I will be able to dim the light here, so that particular aspect of lighting a bulb with it I will be doing, but maybe in subsequent videos. Alright, thank you for watching. I hope to see you in another exciting video. Thank you.